Okay, our next presenter is Autumn Cool. She's an archaeologist with a special interest in studying hard-to-reach places. She has piloted drones, analyzed thermal imagery, operated ground-penetrating radar, and now she works with Bat Conservation International, inspecting abandoned mines across the Colorado Plateau. And her topic for us today is recent surveys of abandoned uranium mines demonstrate the necessity of subterranean investigations for cultural resource inventories.
Hi, so I've definitely shortened up that long title. So just to reiterate, I am an archaeologist, but I also work with Bat Conservation International. Many of you have heard my colleagues in previous years expound on the importance of conducting subterranean investigations when conducting wildlife assessments. And today I'm going to make another case for subterranean investigations based on the value that they can add to cultural resource inventories. So archaeological surveys are often only included in AML projects because cultural compliance is federally mandated, and I have worked on enough projects ranging from AML to pipelines to housing developments that I am aware some project managers see cultural surveys as just another layer of red tape to get through. But I did want to start with a little plug about why I care in cultural resource surveys and why we should be invested in conducting thorough quality work. Oops, it is already skipping ahead of me. Okay. So most of us who are in archaeology enter the field because we are genuinely interested in the past and we want to understand and preserve the stories of those who came before us, especially the untold stories. Written historical texts were usually created or funded by only the most powerful figures, so successful military leaders, politicians, and aristocrats. And if we only rely on those written stories, we're going to have a very disproportionate and biased view of the past. Regular people, like those of us in this room, rarely left written records that actually survive to be studied today. In general, so the only way we can learn about people like miners is by studying the material objects that they left behind and the marks that they have made on landscapes. So I want to honor their legacies by telling their stories. So every abandoned mine is a type of archaeological site based on the definitions here. But when archaeologists go out to document an archaeological site, we're not just trying to check them all off a list. Our main goal is to determine if a site is significant enough that it is worthy of ongoing protection and preservation. If it is, we say that it's eligible for listing on the National Register of Historic Places. So how does that actually impact people in this room? Well, if an archaeologist determines that your mine is NRHB eligible, it means that extra precautions need to be taken during safeguarding or remediation. These precautions can vary quite a bit depending on the nature of each specific mine. They could mean that an archaeological monitor has to be on site during closure activities, and that's it. Or they could mean that you can't drive vehicles or heavy machinery across the site, and all work has to be done by hand. They might require that you install a bat gate rather than backfilling a shaft. Or you might even need to pay a historian to spend several months conducting background research to write up what we call a historic context about the region where your mine is located before any ground penetrating or disturbing work is allowed to proceed. So therefore, any determination of significance impacts everyone involved in AML. It can cost time and money. So doesn't it make sense to make sure that we are investing upfront in thorough and accurate surveys? So how do we make those determinations of significance? We start with the 4 criteria, A through D. A, was the site the location of an important event, or did it contribute in a notable way to an important historical event? So not every small uranium mine that happened to be operating during World War II is going to be eligible under criterion A, but if there was a very extensive uranium mine that contributed a significant amount of ore to the Manhattan Project, and we can demonstrate that through our research, that mine could be eligible for the NRHB under A. B is a site associated with a notable historical person. And by associated, we don't just mean, did Marie Curie visit this mine once? That is not enough. We mean, did Marie Curie live in this location? Or is this the place that we know she collected her samples from for her groundbreaking research? That can make a site eligible under B. Criterion C is asking, is this a very well-preserved or very unique design? And criterion D is asking, if we were to continue studying this site over time, would we be able to uncover new and important information about the past? In general, criterion D typically applies best to prehistoric sites where artifacts and features might be buried under the ground and an excavation could uncover new information about past cultures. But you can also make a case that criterion D could apply to a mine with extensive unexplored subterranean workings. In addition to the 4 eligibility criteria, an archaeological site also has to retain most of these aspects of integrity in order to be eligible for the NRHP and worthy of preservation. Some of these aspects of integrity can be a little subjective to assess, but generally we're trying to think about, has the site or the main features of the site been moved? Has the landscape around it been turned into a strip mall or otherwise modified? Are the features still in the same shape that they were when the mine or other site was active, or has it been reconstructed or heavily modified? And finally, can you tell what this site is by looking at it and what its significance is by looking at it? So most cultural resource surveys of abandoned mines are unsurprisingly limited to the surface, which I absolutely agree with. Abandoned mines are incredibly dangerous and not everyone should go into them. You need to make sure that you do have proper training and equipment, as tempting as those holes in the ground are. However, I think some archaeologists are so used to investigating only the surface that we begin to forget key facts when we're making those assessments of significance. 1, surface plants and surface remains are secondary features. They were never the true locus of mining activity. Therefore, surface-only surveys based on surface-only assessments exaggerate the significance of features like ore bins and compressor pad foundations. It's also redirecting attention away from the central activities of mining and the actual lived experiences of the miners who spent the vast majority of their time underground. How can we claim to accurately determine the significance of a mine if we're only inspecting the small peripheral portion of it? It's like trying to determine the quality of a smartphone by inspecting the case that it comes in. We do try to supplement our knowledge gaps with archival research, but mine inspection reports can be difficult and time-consuming to track down, if they even exist. So most compliance-driven inventories only include a cursory review of archival documents. And as an aside about archival documents, there's a potential problem with relying on historic documents only. That data can be really out of date. Here's an example from the BCI archives. Our subterranean team was planning to do an investigation of the Snyder mine, actually managed to track down a bunch of great information from the 50s that even included maps of the mine workings, which is pretty rare to find. The documents stated that the mine was a 260-foot deep shaft with 3 lateral drifts. However, when our subterranean team got out there to explore, they found that the shaft was over 500 feet deep, and there were additional shafts in the surrounding area that had not been recorded. Obviously, the documents they found were way out of date, so while archival research is helpful, it's never going to be the final word. Another major flaw with conducting surface-only surveys is that they are relying on an a priori assumption that there is always going to be a one-to-one relationship between the surface expression of a mine and its subterranean character. This is a flawed assumption. It does not consider that surface remains can be removed or destroyed by material salvaging, past reclamation activities, landslides, forest fires, and other natural and human activities without having had any impact to the subterranean workings of the mine. Likewise, a well-preserved surface plant does not necessarily indicate that the associated mine has been similarly well-preserved. So how can we judge the physical integrity of a mine if we're only inspecting a small portion of it? Next, The size and complexity of a surface plant does not always match the size and complexity of the mine itself, even if the surface and the subterranean features have both been perfectly preserved. Some mines have always had a discrepancy between their external and their internal nature. In the past, mine promoters and investors have sometimes paid to construct large and elaborate surface plants for mines that just turned out to be barely more than a prospect. Some of these investors and promoters were just really naive and overconfident that their mines would turn out to be very productive and successful. And sometimes they were straight up con men that just wanted to put on a good show so they could rope in more investors and take off with the money before anyone realized that the mine was a sham. Going in the opposite direction, a really poorly funded mine may still have extensive internal workings developed slowly over time through backbreaking labor, but the surface plant might just be lackluster, cobbled together materials. So whatever the reason, these incongruities aren't going to be detected unless a subterranean survey is conducted in addition to a surface survey. Here's another example from the BCI archives. This shaft in the FAO group of mines appeared to be very isolated, and it was not associated with a very significant waste rock dump. From the surface, it looked like it was only about 50 feet deep, so we assumed it was a pretty small prospect shaft, something that archaeologists would not consider significant, and you guys would be able to backfill, close however you wanted. However, we did conduct a subterranean survey, and guess what? This tiny shaft was actually connected to 3 different drifts and over 3,000 feet of internal workings. That is a huge, unexpected difference. Also, within mines, there can be information that can help us learn more about the identity of the people who worked there, information that's not always available in historical records, even if historical records exist. Miners may have left behind tokens, talismans, personal documents, or even religious shrines, like in this illustration. They may have drawn graffiti on the walls, and even the methods used to develop a mine can help identify who worked there. Dr. Paul White of the University of Nevada, Reno has shown that Cornish and Spanish miners tended to create very geometrically consistent mines with regularly spaced drifts and crosscuts because they were paid by the yardage of material that they removed. On the other hand, Chilean and Mexican miners tended to only be paid based on ore quality, so they followed ore bodies directly, leaving behind a twisting and irregular maze of tunnels. These identifying features can only be found by investigating inside the mines. And then one final reason to include subterranean investigations with cultural resource assessments of abandoned mines is that mines have often been repurposed by enterprising individuals after abandonment. Sometimes old prospects or drifts were converted into living quarters for miners, as in this photograph. And there was a discussion during the Cold War about using abandoned coal mines as fallout shelters. These secondary uses are generally not going to be apparent to someone conducting a surface survey of a mine. Maybe there would be a few more domestic artifacts like empty food cans lying around on the waste rock dump, but that alone is not going to be enough to clue an archaeologist like me into the fact that people were living in this mine and not just working there. Only a subterranean survey can provide that information. So how do we deal with this problem? Obviously, there's not an easy solution. Most archaeologists are not going to have the training, even if they have the will, to go inside mines. And we don't want to tell people to do that on their own without proper training, equipment, and authorization. But there are organizations out there, like Bat Conservation International, that do have some highly trained and experienced subterranean survey teams. So if BCI is already conducting your bat surveys for you, which we ought to be, better be, call us, we'll do it for you. Put your archaeologists in touch with us. Our subterranean team will share our photos and we'll share our maps that we make inside the mines. And I'm sure we're not the only ones out there doing these rare but incredibly important subterranean surveys. In addition, this isn't going to answer all the questions, but it will at least help us get a better sense of the scope and extent of mines is by investing in conducting a statistical analysis about the ratio of waste rock dumps to the extent of internal workings. I know the DOE already measures the area and volume of waste rock when they're conducting their verification and validation reports or their inventories of drum sites. And BCI has been conducting LiDAR scans inside mines for quite some time now. And we are in the process of purchasing a drone-mounted LiDAR system that will be able to fly over sites so that we can analyze surface remains and waste rock dumps. So why not use that data to work on developing algorithms that compare the size of the dump to the size and complexity of the mines? It'll help improve the accuracy of cultural resource surveys because we'll know at least a sense of the size and complexity and therefore the importance of the mines we're studying. And it's also going to help land managers because they will also have a sense of where are the large mines on their land that need to be inspected more frequently for new subsidences, and which mines are pretty small and you don't need to check up on quite as often after closure's been done. This is a task that I know will take a ton of time and will require data from many different types of mines in many different landscapes, but it's something that we have the technology available to do, and we could at least start accumulating that data now and to work towards this goal. And then, of course, all of this are long-term goals, conducting those underground surveys, conducting that statistical analysis, so we do still have to fall back on the old archival research. But what that means if we want accurate eligibility assessments so we're not unnecessarily delaying or avoiding remediation, and so that we don't inadvertently destroy an important cultural heritage site because it didn't look important just from the survey, we need to encourage and allow time for this archival research to be conducted. Better to budget for an extra week or two of research up front so that if a mine is determined to be significant and safeguarding methods do need a redesign to protect the site, you can feel confident that those measures are actually justified. And we need to invest time and energy into digitizing what records we do have and making them available to researchers through online databases to facilitate this research. You shouldn't have to drive 8 hours to dig through disorganized filing cabinets at the back of the BLM office for a day and then drive 8 hours home again the next day, which is what I've done a few times this summer. Let's get that information at least hosted by the agencies themselves so that authorized researchers can access them when and if needed. This includes both historical mine assessment reports, modern inspection reports, and subterranean maps from organizations like BCI that get the chance to go inside and scope out the mines. And that is all I have for you today, so thank you. And let me know if you have questions.